Today, we're diving into one of the biggest challenges in all of engineering, how to rebuild the human hand. It's an incredible journey, trust me, from the simplest devices of the past all the way to futuristic limbs that you can control just by thinking.
Think about it for a second. How do you even start to rebuild something like the human hand? It's not just a collection of fingers and a thumb. It's this masterpiece of biology that can crush a can or perform delicate surgery. It's, you could argue, the most complex tool there is. So where on earth do you begin?
Well, you start by trying to grasp the sheer scale of the problem. That number 20, that represents the degrees of freedom in a human hand. That's over 20 different ways it can move, bend, pivot, and rotate. It's just an unbelievably complex piece of machinery.
And that complexity, that really brings us to our first section, the ultimate challenge. Because before you can even think about building a new hand, you have to get what our own hands can actually do.
A really successful prosthetic has to do way more than just open and close. It's got to be able to copy all these different grips we use every single day without even thinking about it. You've got the power grip for grabbing a heavy bottle, the delicate precision grip you need for a pen, the lateral grip for turning a key, and, of course, the incredibly important thumb opposition that lets us touch each of our fingertips.
So now, let's take a look at how people first tried to tackle this problem. We're going to jump back in time a bit to the very first prosthetics, and believe me, they are a world away from the bionic limbs we see today.
The journey here has been a long one. Way back in ancient Egypt, any kind of replacement hand was just for looks. It didn't move at all. Then you get to the Middle Ages, and we start to see the first functional devices, like metal hooks for soldiers, but they were super basic. It really wasn't until the 19th and 20th centuries that the focus truly shifted to restoring actual function for everyday life.
And the big breakthrough of that era was the body-powered prosthesis. It was such a clever mechanical solution, really. Just by shrugging a shoulder or moving their chest, a person could pull on a cable that would then operate a hook or a hand. It was simple, it was reliable, and it was powered completely by the person's own body.
But then, a revolution happened. And that brings us to our next section, the bionic leap. This is where we say goodbye to the world of cables and harnesses and hello to the age of electronics, batteries, and microprocessors.
You can really see just how big of a leap this was when you put the two systems side by side. On the one hand, you have the body-powered device. It's tough, it's reliable, but it needs a bulky harness and takes a lot of physical effort. But on the other hand, the Myoelectric system, it's powered by a small battery and you control it with your own muscle signals. It's way more discreet and so much easier to use.
Okay, so how does this whole muscle signal control thing actually work? It's a really cool four-step process. First, the user just tenses a muscle in their arm, like they're thinking about moving their hand. Second, these little electrodes sitting on the skin pick up the tiny electrical spark from that muscle. Third, a tiny computer inside the hand figures out what that signal means. And finally, boom, it tells the motors in the fingers to move. It's this amazing direct link from your intention to an action.
Here's a fantastic way to think about it. Those EMG sensors, they're basically like tiny little microphones. But instead of listening for sound, they're listening for the super quiet electrical hum that your muscles make every single time they move. It's just an incredibly clever and sensitive solution.
And that brings us right to the cutting edge, where the connection between our minds and these machines gets even more direct, even more intuitive. We're talking about literally thinking a hand into motion.
Now check this out. One of the most brilliant advances is this surgical procedure called targeted muscle reinnervation, or TMR. What surgeons do is they take the nerves that used to control the missing hand and they cleverly reroute them to a different muscle, like in the chest. So now when the person just thinks, "close my hand," those old nerve signals fire up and they cause that chest muscle to twitch. The prosthesis picks up that twitch and closes the hand. It's like they've created a brand new, totally intuitive control panel right on the person's body.
And then, of course, there's the ultimate frontier, the brain-computer interface, or BCI. This is where electrodes are actually reading signals directly from the brain itself. Now, this is still highly experimental, mostly happening in research labs, but this tech allows someone to control a robotic arm just by thinking about the movement. It is the most direct mind-to-machine connection you can possibly imagine.
So, with control technology getting this incredibly advanced, what's next for bionics? Where does the research even go from here to make these devices feel even more like a natural part of us?
Well, a massive area of research is sensory feedback. The whole goal is to close the loop. See, right now, the user controls the hand, but the hand doesn't really send any information back.
Future systems are going to use sensors in the fingertips to send signals back to the user's nerves, actually allowing them to feel the texture of an object, or maybe even its temperature.
Another absolutely groundbreaking idea is something called osseointegration. This involves surgically implanting a metal rod directly into the bone of the arm or leg. The prosthesis then just clicks right onto that rod. This completely gets rid of the need for a socket, which can be pretty uncomfortable, and it creates a much more stable, solid, and intuitive connection to the device.
And you knew this was coming. Artificial intelligence is playing a huge part. The next generation of bionic hands will use AI to actually learn a user's habits. The hand could start to predict what kind of grip is needed for a specific object, making every movement smoother and more natural. It stops being just a tool and starts becoming more like a true extension of the user's will.
All of this incredible innovation really leaves us with a final and pretty profound question to think about. As these technologies become more integrated, more intuitive, when they even start to provide sensation, you have to ask, where does the body end and the technology begin? That's a question we're all going to be exploring for decades to come.